Hi, Assalamualaikum and a very good morning. So in this video, I will show you how to answer this question. This is an example of hydrostatic force on plane surface where the plane is inclined at a certain angle. So in this case, we have the gate or the plane surface that is in orange color here. Okay. It is inclined at 60 degree and it is attached to a cable. Okay, so the water in here in here will give pressure force onto this plane surface. So this pressure force is called as hydrostatic force. Okay, and at the same time we also have weight of the gate that is given as 3.6 kilonewton. So you need to determine the tension in the cable. So before that you need to draw the free body diagram so that you know what are the forces that act on this in this system. Okay, so we have weight is going down, so the weight is acting at the centroid of the whole length of the gate, which is 2.4 meters. Okay, so half of 2.4 meters is 1.2 meters. Okay, so this is the shape of the gate. So why I draw it up to this point, because when you want to calculate the hydrostatic force, we only consider the length that is covered by the water only, which is 1.8, not 2.4. Okay, so the length is 1.8 and the width is 1.2. Okay, so hydrostatic force, when you calculate the hydrostatic force, you must consider the length that is covered by water only. So we have to have another centroid for this um, plane. Okay, so this is another centroid. Okay, this is the centroid for the whole length. This is another centroid. So this centroid is only for the length that is covered by water. So this is half of 1.8, okay, which is half of 1.8. So the h bar, which is the vertical distance that is taken from the water surface to the centroid, is here. Okay. H bar can also be called as hc. And the inclined length, okay, from the water surface, intersection of the water surface and the gate and the centroid, is called as y bar. Okay, so y bar can simply be measured by using half of 1.8, which is 0.9 meters. So hydrostatic force must be perpendicular to the gate through Cp. Okay, it acts through Cp. Cp is center of pressure. Okay, so Cp must be slightly lower than this centroid. Okay, the second centroid here. So the distance from the centroid to the Cp is called as yCp. So normally we need to find the perpendicular distance from the force to the hinge, because when we take moment, we take force times perpendicular distance. So the perpendicular distance is called as y hinge. So you can call any name. I simply call it y hinge because I refer to the hinge. Okay, so there's no specific name, there's no specific formula. So you have to refer to your diagram. So how y bar and h bar is related? You can draw a triangle here. You can use trigonometry. So h bar is the vertical distance while y bar is the inclined distance. So it is related with this angle 60 degree. Okay. Sorry, this is how to answer it. So I will show you how to answer it. So you need to follow the steps that I mentioned in the previous example. Okay, so the first thing that you need to do is to, still in red color, it's okay. So to find the FH. Okay, so to find the FH, the first thing that you need to do to find H bar. So H bar is the vertical distance from the water surface to the centroid. So since sine 60 is equal to H bar equals to divided by Y bar. So basically H bar is Y bar sine 60. So since we know that Y bar here is given as half of 1.8, 0.9, so you can simply calculate this 0.9 sine 60. So you should get 0.799 meters. So the next step is to find the area. So the area that is in contact with water, which is covered by water only. So width times length. So width is 1.2 while length is 1.8. So you should get 2.16 meters. Okay. Then only you can find the FH. FH is gamma H bar E. Okay. So you write 810 times 0.799 times 2.16. So you should be able to get the answer. It's in kilonewton. Then you need to find Y hinge. Y hinge is the perpendicular distance from the force to the hinge. So the first step is to find Y bar. So Y bar is 0.9. Okay, and then you need to find YCP. So YCP is by using this formula, IXC divided by Y bar A. So since this is a rectangle, if you refer to the diagram is normally attached or provided in the appendix of the past year questions. You can refer to that. So for a rectangular shaped gate, it's BH cube or BA cube. BH cube or BA cube. Same. A or H is for length or the height. Y bar A. 12 Y bar A. 12 Y bar A. So width is 1.2. Okay, sorry, I continue below. Width is 1.2. Height is 1.8. Only covered by water. So 12 Y bar is 0.9. Okay, and area is 2.16. Okay, so you should be able to get this as in meters, and then only you can find the Y hinge. So basically Y hinge is, if you see in your diagram, half of the gate, which is 0.9 minus YCP, that is your Y hinge. Okay, so to get the tension, you have to take the summation of moment about the hinge. Okay, it's equal to 0. So the counterclockwise forces counterclockwise forces is the tension. Okay, you take the component. So tension, the distance is the whole length, which is 2.4. It is sine 60. I believe it's sine 60. 60. And then you minus with the weight, also the component. So weight is half of the gauge, is 1.2. So cos 60. Okay, and then the hydrostatic force is Y hinge. I believe that I have to continue below here. FH times Y hinge goes to 0. You rearrange this so that you get your tension lah. You want to find tension, right? Okay. So the answer is 5.8 kilonewton. I believe the answer is 5.8. You can try on your own. Okay. So I will show you the this is the answer. I show again. Okay, so this is the answer. Okay, you can try on your own. If you have any question, you can ask me. Thank you.